You should have on the back of 87, 88. Yeah?
I love these problems.
Okay, here we go. Are you ready? Do you do this in Algebra 2? Is this review or totally new? You've done this in this class?
Well, you did that differently at the beginning of the
We did it base E or base like 1 plus the growth rate off?
I like this one.
We did it that way.
I learned it
This way.
I like it.
Good.
I've never seen
You never seen it. Okay. Good to go.
We did this. Let's start this in the beginning.
And,
Just because we did it all the time does not mean I knew it. Or
okay. This is a huge idea of both business and science. It's very useful. Okay, so here goes. Let's go with this. We're going to call it exponential growth. And when something grows exponentially, it's important to understand how powerful that is. The parts you're going to need to know are that the y-intercept, it doesn't start at 0, because if you think of it like doubling, doubling is the most basic form of exponential growth. If you start at 0 and double over and over again, then what does it stick? 0. If I take 0 and double it, I get 0. And if I take it double that, I get 0. So it can never start at 0. Exponential growth, unless it's been shifted down, never starts at 0. It starts at some initial amount. This is the amount at different times. Okay? This axis is the time. Now, let's use the idea of, actually, let's just go with this. The idea is that it curves up because it grows really fast. Think about linear growth versus exponential growth this way. If I say the population goes up by 100 every year, wouldn't it just always go up and over at the same rate? Up 100 over 1, up 100 over 1, up 100 over 1. That's linear growth, right? But if I said it doubles every year, then the first time when I was this much, it would double, and then in 1 year it would be here. But in year 2, if it doubles this new amount, wouldn't it grow by even more? And then it's going to double by this amount. Exponential growth then is really powerful growth. That's the part you need to understand. Now, look back at the equation here. We're going to peek at this as we go here. This is the main equation for exponential growth. A initial certainly is the starting amount. Now that makes sense because at time 0, what is e to the 0? 1. Okay, not 0. Remember, e to the 0 is anything to the 0 power is 1. So that would make sense that at time 0, the amount is just the initial amount. You follow? That's what this point indicates. Are we cool? Now, the bigger the k, the bigger the exponent. And the bigger the exponent, the faster it'll grow. So if we were to do, let's just say two curves here, do maybe one that grows a little less. This one would be a bigger k, and this would be a smaller k. But they would both have to be k is positive. That's how it's growing, by a positive curve. Cool? You with me so far? Okay. So before we get to the next graph, let me remind you of something you already know. Y equals e to the x looks like this, yeah? What about y equals e to the negative x? What does that negative do in terms of graph transformation?
Over the y.
Flips it over the y-axis so it looks like that, yeah? So when you have a negative exponent, rather than growing in the positive time quadrant, it's going to decay. Exponential decay is when you start at some initial amount and you get smaller. Now, you're still gonna have a horizontal asymptote. It never will be zero. Just like if I take a half of a half of a half of a half, assuming I started with something, I can never get nothing by taking half each time. I'm always gonna have something still there, right? Are you with me? This guy also has a horizontal asymptote, but it's over here. We don't really look in that part. Okie dokie. Now, this happens because k is negative. So if you have a positive k, it'll be exponential growth. Right, gentlemen? And if you have a negative k, it's exponential decay. K is the constant of growth or decay. It's problem specific, so one problem, one type of substance might have a growth rate of this, and K will be one number. And then another problem you go to, and the growth rate will be something else, and K will change for that problem. T is the time since time 0 in whatever units. A sub t is the amount at time t. So it might be A sub 30, amount at time 30, whatever. A naught or A null or A initial is the initial amount at time 0, the starting point. You follow? Okay, these problems go pretty well. I think you'll be fine. You will need a calculator. So if you don't have a calculator, grab one. Exponential numbers tend to be pretty gross and easy to 55. It's pretty good. All right, are you ready? Okay. If you're using one of my calculators, choose the blank one. Okay. So, the number of bacteria present at noon was 400. 9 hours later, the bacteria numbered 800. Assuming exponential growth, find the amount of bacteria present at noon the following day. So, let's go with, I'm not going to graph this beautiful. I'm just going to, what I want to see is that you know the y-intercept. What's the y-intercept? 400. It's the starting amount. T in this case represents the amount at time noon the first day. Also, again, it doesn't have to be pretty princess. Just tell me another point and show that it's, that you know this is growth, not decay. Hi, thank you. All right? It's just communicating to me that you know the starting point and growth versus decay. Are we cool? Okay. And it should curve, not be linear. All right. Now, using this equation, let's talk about what they're giving us and what we can put in. So I'm going to let noon the first day, that I'm going to call it the initial time, the starting point. Okay? So what is that 400? Is that the amount after time, the amount at time 0, the k, or the t? E, by the way, is a number. It's not a variable. What is it? Yeah, so that's 400. Cool. 9 hours later, the bacteria numbered 800. Where can I put that in my equation? 9 hours later, what does that seem to indicate? Time. Okay, so that's a 9. And what about the 800? That's A sub t. That's the amount after time. That said, then A, or E is still E. E is always E. And K is unknown. Now, because of the two cases they give us, we can find K. If we know K, then we can answer any other question coming down the pipe. So how would I solve this for K? This is where you need your pre-calc skills. Undo. What do you get rid of first? Okay, so that's 2 equals e to the 9k. Do you see where I'm coming from with that too?
Yes.
Okay, feel free to show it if you want, but I think you see where that's coming. Now what do you got to get rid of? The e, the k. The e. You log both sides, and when you log both sides, you get log of 2 on the left, and what on the right? 9k on the right. And therefore k is? Natural log 2 over 2. You see where we're coming from? Okay, now, the amount, we actually know the amount at any time equation. The amount at any time is 400 e to the log 2 over 9 times whatever time. We know the general equation for this. We can answer any question they give us. You follow me? Now the question they ask me is, find the amount of bacteria present at noon the following day. So noon the following day means what time? 24. Is 24. Time, 24 hours later. So A sub 24 is what you're being asked. The amount after some time, what the time I'm asking for is 24. Is 400 e to the log 2 over 9 times 24. Throw that into your calculator, and we'll round it. Would you give me 3 decimals, then round it to the nearest whole, bacteria and all, you know. It's pretty common in AP, at least in AP calculus, that you show the decimals then round. So, would you give me 3 decimals? 2,539.842, and rounded to the nearest whole is 2,540 bacteria. You follow? You don't have to write more bacteria. I would say if it's grams, like, you know, exponential decay and radial decay, then yes. But, yes. What? I want the both. Okay. All right. The number of the number of penguins in a population started at 1,200, which reminds me of a joke. What do you call a penguin walking around in the desert? I thought it was worth it. But I digress. Okay. So after 100 days, I thought it was funny. After 100 days, there are 2,700 penguins. I'm an easy laugh. Assuming exponential growth, found the amount of time required to reach 30,000 penguins. All right. So, what do we do to get started here? Typically, you'll almost want to take the 2 given cases to find K. So what do you know? The 1,200, where's it go? A naught, or A initial, 1,200. And what else do you know?
2,700 going to A.
A sub t is amount after time, and we know an amount after time. 2,700 is an amount after time. How long does it take to get there?
100 days.
So where does that go? E, K, or T? T. All right. What's the arithmetic I do to solve for K?
By natural law.
Divide by 1,200. If I divide by 1,200, and I'm just going to drop the zeros, we can reduce it more, but that's easy for me. You with me?
Yes.
That's still e to the 100K. Then what do we do?
Natural law. Natural law.
Log both sides. So that's log of 27/12 equals, what is the natural log of e to the 100K?
100K.
Just 100K. The natural log and e drop away, which is the whole point. And then
K equals.
divide by 100. So K is natural log of 27/12 over 100. Okay? So the first thing you do is use the given cases to find K. Are we cool?
Yeah.
Then would you take stock and write the equation? Now that your equation is complete, the amount at any time is always 1,200 is the starting amount, e to the log of 27/12 over 100 times whatever t you put in with. You down?
I'm down.
Okay. All right. Now we come to the question. Assuming exponential growth, find the amount of time required to reach 30,000 penguins. What do we put in? What do we solve for?
AT is 30,000.
Yeah, A sub t is the amount after time. It's 30,000. It's 12,000 e to the log of 27/12 over 100 t. Okay, now this is where it starts to become a little bit of writing. So maybe we should just call that in our mind K, shall we? Do you mind if we just call that K?
I can
Because
live with that.
I have defined what K is, so every time after that, when I say K, people should know what K is. You with me?
Yes.
Alright, plus it'll be a heck of a lot of writing, and it'll be easier to put in our calculator. So, what do we do?
Move 1200.
Move the 1200 over. You wanna drop a 0 or 2? I'm gonna. Do you mind 300 over 12? You can divide all the way if you like. Okay? E to the KT, then what? Oh, sorry, 300 over 12. Then what? Natural log of both sides. Log of 300 over 12 is KT. So T is
Divide by just A.
log of 300 over 12 divided by K. Now, I would probably do this in your calculator in 2 steps. Find K and store it, then use K in a later calculation. So please calculate, what did we say K was?
Natural log of 27.
Okay, so K is natural log of, okay, so K is, you said natural log of 27 divided by 12 divided by what? 100. Okay, do you remember how to store? Do you know how to store?
Yeah.
Okay, here, control, store. You're going to put that in K. Cool? All right. Tell me why it makes sense that K is a positive number. Because it's increasing. It's such exponential growth. Right, Mr. McCabe? Okay, so when I then find the time, I'm going to do log of 312 divided by K. I reduced it a little. You don't have to reduce it a little, but log of, oops, I'm going to go with this guy. Log of, log of 300 over 12, is that what I said? 12 divided by K, which has been stored. I get 396.9362, is that what you get? Okay, so reporting our answer, time is 396.396. What are the units on time? Days. There is no reason to round time. You can have part of an hour or day. Yes? I do want you to draw the graph. The homework will require you to draw the graph. So what's the y-intercept? 1200. And is this exponential growth or decay? That to me is enough right there. Okay? Should we show the second point? Should we show the second point they give us? You're right. Good call.
Good call, Hannah.
Good call, Hannah. You're a champ. Okay.
Thank you, sir.
You're welcome. Oh, I love sir. That's awesome. All right. So the initial amount of bean dip was 400 pounds. I love bean dip. I love bean dip. And then Miss Cannon appeared. After 90 minutes, there were 380 pounds left. Assuming exponential decay, determine when half of the dip remains. What is decay then imply? K is negative. Okay, we'll find a negative K here. Get me started. What do I do? Okay, what can I put in? Mr. McCabe, give me something here. What can I put in? Initial A was 400. Cool. Okay. What about the other stuff I can put in to find the K? What else can I put in? 380 is A sub T or K or T? A sub T. It's amount after time. And what's the T?
90 minutes.
90 minutes. Cool. Okay. So, let's do this. How will I solve for K?
Divide by 400.
Divide by 400. I'll call that 38 Furious equals E to the 90K. Then
Divide by
Natural log.
natural log to get rid of the E. Natural log of 38 Furious is 90K. Then divide by K. Natural log of 38 Furious divided by 90. Feel free to calculate that and store that to K. Okay? You have that in stored for K?
Yes.
Okay, cool. Now, the question, assuming exponential decay, determine when half of the dip remains. So, what is, what am I gonna do? 200 is the amount after time,
Yes.
okay? What's the initial amount?
400.
And I know K, and I'm looking for
T.
T. How do I solve this for T? Divide by 400. 1/2 equals e to the kt. Then
Natural log.
natural log of both sides. Natural log of a half equals kt.
Stop it.
K, or T is natural log of a half divided by K. Do natural log of a half divided by your stored K. Put on some units, and we'll call it good. What do you get? 1,216. I think this is pounds so, or times, so we can do decimals. 1,216.207 in the units. Minutes. Okay. In terms of the graph, what's my y-intercept? 400. Do I put it high or low? High. Because I'm going to
You're decaying.
decay. Should I cross the axis?
No.
Should not. There's an asymptote there. Okay? All right. What's the other point? 90 minutes, 380. Ooh. All right. Are we cool? All right. This is the hardest one. A radioactive material decays exponentially. After 100 years, 500 grams are left. After 200 years, 300 grams are left. What's the initial amount? We don't know the initial amount. So, this is wonderful and it's super duper, but you're going to have to do a little bit of thinking instead. Okay, we're not going to be slave to that equation. We can use a little bit of an adapted form. Tell me, how would the 100-year and 200-year cases relate?
Well, 100 years apart.
100 years apart, okay? So let's think of this as, temporarily, let's think of this as my initial amount, okay? Couldn't we say that the amount after 200 years is like starting with the 100-year case and changing?
Oh, yeah.
Okay, so think in more general terms, this is the later time and this is the earlier time. If in a case they don't give you the initial, then do it more like earlier time changing to a later time. Cool? Now thinking of it that way, ends for a 200 is what? What's the amount after 200? 300. Okay. What's the amount at 100? 500 grams. E to the K, and what's the time it takes? 100, because that's the time it took to get from the 100-year case to the 200-year case. This is the more like the time change from 100 to 200. You follow? Okay. Now with that, I can still find K. What do I do?
3/5.
3/5 when I divide by 500 is e to the 100K. Then what?
Natural log.
Natural log. Log of 3/5 is 100K. So K is,
Natural log of 3/5 divided by 100.
okay, store that to K. All right. Now, we can, actually they asked two questions. Find the initial amount of the material and then find the half-life. We'll come to that first. Let's find A initial. So, now we can find A initial how? Now that we're bringing A initial into it, can we go back to our classic equation?
Yeah.
Okay, so what can I put in?
K.
K, we know K, that's cool. What else? Do we know an amount at time? Yeah, we actually know two places at time. Doesn't matter which one you use. Which one do you want to use? The 100-year case? Okay, so we can say there's 500 there at the time point of 100 years, right? And what don't we know? The initial. So how do we solve for initial here? Do we need to take logs? No, we want to get rid of multiplying by e to the 100k. So to get rid of that, we divide by e to the 100k. So A initial is 500 over e to the 100k. You should have k stored, and that should be fairly okay to calculate. Give me what you have at 3 decimals. Out of 3/5 over 100. Log of 3 divided by 5 divided by 100. Did you get k of negative 0.005? Okay. Then did you get something like, what was I dividing again? 500 divided by e to the 100k. 500 divided by e to the 100k. I didn't store that k. Oh well, I just use answer. K, did you get 833.333? Okay, 833.333. And what are the units on that? Grams. Last but not least, the half-life. Let's go here. Half-life is the time it takes to half the amount. You cool? Now, I have the initial amount, and I could put 833 in here. And I could take half of that. Isn't the amount after time then half of that? Are you with me? But right away, what's going to happen when I divide 833 over? It's going to turn into a half. So do I even need to put in that 833, or could I just say that's could have been 100 grams and went to 50, and it's going to be a half when I divide out 100? Are you with me? Or could it have just been 2 grams going to 1? So my point is, you can put in the initial amount, but if they didn't ask for the initial amount, you wouldn't even need to fund it. You could just say, I'm going from the initial amount to half the initial amount. You're always going to end up with a half over there. For this case, most students like to just say, we got the freaking initial, let's just use it. All right? So, my question is then, how do I find, what am I trying to find? Let's start there. T, the time it takes to half the initial amount. When I divide this 833 over, we just said that this will just be a half equals e to the kt. You cool? Then what? Log of both, you can, yes. Log of both sides, that's a half equals kt, so t is oops, natural log of a half divided by k. What is the half-life? 100? 35.692?
Yep.
Okay, last thing I'm going to ask you is tell me why that makes sense. This is yours. Okay? In the case they gave us, they went from 500 to 300. Was that half or not quite half?
Not quite.
So to get half, would it need to be a little more than 100 years? So it makes sense. This initial amount was 500. It went down to 300 in 100 years. Exponential decay, something like that. I missed my mark. You get the idea. Are you with me? Okay. Would you prove to me that you can do this? It's a bony population problem. You AP Bio people know that this is actually not being true. You require logistically for a carrying capacity, right?
Spoon.
But carrying capacity makes it harder. Okay, You want whiteboards, half sheets, anybody want notes? There's little papers if you want a little paper. Whatever you like. If you want a marker, that's cool. I'm gonna do the problem so I can check your work effectively. And here we go. What do you say? Ending. Sorry. Hi. How are you?
Good, how are you?
Super. Thank you. Thank you. Oh, should I draw it? Draw it. That's not what I got. I agree with the kid. Boom. Thank you. Oh, I should bring the recycling on. So people don't. Who's that jersey?
Oh, I just found this at a thrift store.
Oh, yeah. All right, cool. Hello. Thank you. Thank you. Go around time. Thank you. Thank you. I like that people are laughing, and I didn't ask, but that's good. I didn't need it. Thank you. Hey, thank you. Hello. Okay. Yeah, thank you. Better? Thank you.
23.
Game forward. That's the hood. Short cut. Is that too much work to ask of you, Hannah? It's not. Time can be decimals, time can be parts, yes, include decimals.
Where's my lock?
3 decimals. Hello, how's it going? Hello.
Oh, I have to draw pictures.
Paper stack feels big. How come people haven't taken it to home?
I just was coming to some kind of shade this.
Well, I'll just say that. Thanks. I'm getting backed up on all this now.
All my numbers are different now. Okay.
Devin, Bashar, you good?
Got back finally.
Who else? Katie? Who else hasn't got this paper?
We got a negative answer the first time that we did it.
Oh, what happened?
We switched around these 20 and the 200.
Thank you. Everybody good? Let's have this.
I do.
Do it yourself, Katie. Don't let them hurt. Yep. 26. Yep. Half the desk. Well, does anybody else not have this yet?
Is that picture?
20 and it starts. Yes, that's fine. Thank you. Okey-doke. Okay, I remind you, tomorrow you'll have a quiz over the most missed questions on the test. If you'd like to come in 7th and go over that test again or get more practice, let me know. We'll do it. Tomorrow there's quiz. Have a lovely day.
I don't think so.
Strangers in the night.
Even though she's still laugh. Thank you.
Thank you. Have a good day. Thank you. Strangers in the night. Two lonely people. We were strangers in the night. Thanks, guys. Have a good day. Let's hope. Hello. How do you do?
They already have DLC. Yeah, they already do. So we learned another DLC. Whiteboard, the bunny population started 2027 days ago, reported bunnies, how many days ago? I think this is pretty tough.
Yeah, I don't think that's us. That looks too easy to be us.
That's not you guys.
I wish.
Me too.
I wish that was today's lesson.
That, I mean, yeah, that'd be awesome, but
I like how the font's bigger, and there's only 25 columns.
My sister.
I have font bigger.
That's 65. This is Madsen. This is Madsen.
Where's Max 65?
No, I don't know. See, so this is Madsen. It's like this one.
So nobody in Evelyn should have to start at Max 7.
Yeah.
You're ready to
Unless
an exciting thing.
you don't.
That can't be right.
Unless you're pretty good. Natural function.
Well, nobody, I would argue that nobody's. But
I mean,
I guess I can.
I mean, because you are in the school, so like.
No, the starting level for Max is Max 7. I don't even have it.
Yeah, maybe it's not.
Yes.
This is in our class. Put it on the desk.
I don't think it's I really don't think this is on. I saw that. Miss Anderson. Skylar, I brought the wrong math book. Yeah, I brought the wrong book. But I have my stats homework. I forgot my homework paper, so I guess we're gonna sit.
Okay, exponential growth, are you ready?
Yes.
Just kidding.
My program.
All right. I'm just kidding, we're not doing that. You're kidding, you've done exponential growth a million times. That's ridiculous. All right. Too bad. Exponential growth. Instead,
He's so proud of us. I never would notice that. What? That's why I gave it to him. So I was watching. He was just like a type of person, and what he does, this is how they argue. Like they stand up and they start yelling at each other. They just yell, like straight up yell. And that head person has to like call out. He's like, what up, what up? And he was like almost like screaming into a microphone that's like yelling. Okay, so I'm like, the room was like
hey, start your scratch work on that paper and I'll have the problem stretching these are There is the paper. You will need to do your proof once you know your delta. Feel free to do your proof on the homework. It is problem number 20. How do you find delta? You start from where and go to where? Start from F minus L is less than epsilon and go to X minus C is less than delta. remember on your scratch work, I don't care how fast you go, for your benefit. Anybody have their delta yet? What is it? 2 epsilon is correct. Continue on if that's what you have. Alright, how did it go? Successfully or not? Well, let's see. Tendency for those that understand the concept is to skip steps. That's the only reason you would lose points. Remember, it is proof. So, if you're not sure where 2 epsilon is coming from, you'll kind of see it in the proof itself, although it'll be forwards, not backwards. But what are we trying to prove when we prove a limit? If, then it must follow. Okay, now that's the definition of the limit. That's the limit is what you say it is if it satisfies the definition of it. That is the definition of a limit. You can get the y values arbitrarily close to the limit, is sometimes how it's said. So we said that x minus 2 must be less than delta, and therefore x minus 2 must be less than 2 epsilon. Where do I go now, my proof?
Assume.
Go off to the side and show them where that 2 epsilon comes from. So you assume x is close to 1, which we'll say is between 1 and 3. All right, what do we try and build up to? 2x. Okay, you're going to want to get 2x there. Now, why? It's still kind of a mystery to the reader, but you know why. You'll see that in a second. What now?
Absolute value.
Yeah, that really absolute value has to be there so that when you move that 2x over later down the line, you don't have to worry about switching the sign. It has to be there. And then an epsilon. You slap an epsilon in there. which is allowed because it's positive, and then you come back and go back to your logic, but now you bring in a new factor. You still know that x minus 2 has to be less than 2 epsilon, but you have demonstrated that 2 epsilon is less than absolute value of 2x epsilon, yeah? Then the trichotomy rule, if A is less than B is less than C, then
A is less than C.
A is less than C, which is to say x minus 2 is less than 2x epsilon. Now the absolute value is important because we're going to divide that over, so x minus 2 divided by absolute value of 2x is less than epsilon. And then you have to go through the gymnastics of getting that to be f minus 1/2. I put them together into a single. You have to split and shuffle the order, or shuffle the order and split, whichever you want. It is okay to change the order because of the absolute value, and then splitting them gives you the end result of 1 over x minus 1/2, which should be x over 2x. Okay, which is f of x minus L less than epsilon. Boom! Okay, wow. How did those go on last night's homework? All right. Today's lesson I'm not going to teach because we're kind of getting backed up. So anything that's new, leave it blank and we'll teach it tomorrow on the homework. So those graphs with the little dots, that won't mean much to you. Lindsay, if you want to do it. But slope fields I'll teach tomorrow, and we'll be good. Here we go. I'm going to go over tests and homework questions. So let's start with the test, shall we? Would you take any phone off your desk? And then as you take your phone off your desk, ask yourself, why did you have your phone out to begin with? That's dumb.
What's the phone?
What's the point? It's just a terrible
It's not an anchor on your ship to success. Am I right? No.
yes, it's dragging you down. You get some weight. You get some lines. Right?
Because it might not hurt. So,
How's the way the shadows of the phone
Not usually. The way we differentiate them. Everybody always says the difference between you guys, but as I
Okay. Still, sorry. I think I did even did worse than Kylie this time. That never happened.
usually there.
I'm 6 seconds off of Mikhail with 500 in this problems.
It's like, I go like 110, C10 through 1. I can rank you. And I almost beat you.
After everyone said that they did that.
Oh, okay. I was like, I got 15 out of 25. How was that 86%?
I used to do this. That was a used to. Oh, yeah, definitely. Now they don't.
Okay.
It's like I better test it.
Here we go.
You don't have enough.
This one, I just can't call it app question, just call it a different name for my question.
So they are changing from year to year.
No.
Okay.
No. Thank God for this.
Question mark on it.
There's
Okay. Sorry. Many people just make silly errors here. This is -4, this is 10. I don't know. Seems like people that put the areas in the figures seem to have a little more success. But either way, figure out why you did that wrong, but you shouldn't have missed that. Does the mean value theorem guarantee a C on the interval? If so, yes, or if not, why not? Yes or no? No, not differentiable, right? Okay, this was on the homework, that went pretty well. In fact, the whole front side of this was pretty good. Let's just say this. This page was the one that you had plenty of time on. I drew the A at 20, this is 27 points, so if you had 24 or above, you had an A. If you had 21, 22, or 23, you had a B. And C was down to 18. Okay, for the most part, this page was great. I cannot remember if there was a consistent source of error. I can do number 3 somewhere. Yes. So, this is one of those where the hardest part of Newton's method in this was getting started. What does Newton's method do? It estimates what? Zeros. It estimates zeros. You have to make a zero problem. So if you want to know where x squared plus cosine of x equals 2x plus sine of x, the very first thing you need to do is make it a zero problem. How do you do it? Move everything to one side. So you let everything equal 0 by moving everything to one side. Some people call this F. I'm not a big fan of that. F is taken. You should have called it something else like H. And then Newton's method from there. I had a handful of people remembering the formula or the Newton's method idea wrong. I had people saying x initial plus. That's not true. It's minus. If you have to develop it, do it, but it's x minus h over h prime at x initials. The correct answer was 0.357. For some people had errors on the deltas. For all these, delta x was 3. Some people put the wrong delta x in there. The fourth one, it was fine. What the heck? Oh. This I was pretty happy with. I guess in retrospect, I wish for length I would have made the first part just calculator so you didn't have to integrate it by hand. I was doubtful. I thought, I don't know. I don't think they can integrate that by hand without making a mistake, but it turns out I was wrong. You guys. Okay, second page. At this point, I don't know if you could do this, you just didn't have time, or you just can't do it. It's hard to say. That's the bad part of too long a test, so let's make sure you can do it. 8A was fine, and 8B was fine. What did you use for an M? Some people did the M wrong. M is the max of the absolute value of F double. I put that on the board with absolute value. And so if you said 1 for the max or something like that, or 2, that's on you, baby. It was on the board. I clearly said absolute value, and so what is the max? 6. Okay, 6, not 2. Some of you wisely said, I don't have time for that, because this is a time constraint problem. Let's talk about it. It seems like a wise choice would be to start by graphing the original function, then talking the absolute value. What do you know about the original function? It has a asymptote. What kind? Come on, talk to me, people. Vertical asymptote at 0, and an x-intercept at 4. And without the absolute value, what's the end behavior or horizontal asymptote? The horizontal asymptote is at -1 before the absolute value takes effect, yeah? I'll do the absolute value in a second. And in terms of the graph, did you get something like, down here, look at -5 or some 0. At a negative, you get negative, yeah? And so it's down here. Okay, and then after you jump 0, it's positive. Sorry, it's taking me a second to think through this. Is that right?
That's what I had.
At 1, it's negative over negative. We're cool. Okay. All right. So, with the absolute value then, wouldn't it look something like an asymptote at +1, yay?
Yeah.
This would be flipped up here. This guy would still stay that way, and then this would go like that. All right. After that then, the integral from 3 to 4. Normal F or negated F? Normal F. And the integral from 4 to 5. Normal F or negated F? Negated. So in some way, I'm just going to leave the negative off the top. Yeah? After that, what's the integral strategy? Split it and integrate it, and you should get natural logs. The horizontal asymptote, I basically did all or none. It is, anytime you do a horizontal asymptote, I expect it to be an equation. So if you just said -1, or sorry, 1, that's not an asymptote. That's a number. What's the equation of the asymptote? Y equals 1. Okay, y equals 1. I did count it for y equals 1. Exactly, that's right. I'll look at it again. Work on your hand. All right. The derivative is probably fine. This is straight out of your homework. I'm going to continue to pull problems from your homework to make sure those of you who are doing the homework authentically succeed, and those of you who are not doing the homework authentically or don't care about your mistakes fail. Okay? Or don't do the homework. All right, last but not least, this is a great problem. I really wish this test weren't too long, because part D is a really separate the men from the boys or the girls from the women kind of problem, whatever. It's a good one. So I want to talk about all this problem, but especially part D. This is going to kill me. You're going to kill me with this. You're going to kill me. The next time I see this going on right here, you and me are stepping outside. That's all there is to it, okay? Because that is starting to tick me off. Can you actually calculate the exact instantaneous rate of change
No.
from a table. You cannot. Will they count out from the IDP test? You better believe it all the time. Please
Yeah.
stop saying an estimate. Start circling that word when you come to it. Estimates, approximates. Okay, please, please. The units on that weren't graded for. They did a separate unit point off to the side. I'll come to that in a second. Hey, what is the integral of velocity give you? Distance or displacement? Displacement. In what condition does it give you distance and displacement? If it's always positive, then it is both distance and displacement. This, I think you'll agree, I hope you looked, but it was negative, so it is not distance, it's strictly displacement. You should say the integral, the meaning of the integral is the displacement of a particle. Somebody put a car, I don't know where you're getting a part from, of the particle in meters from time 20 to time 40 seconds. Okay. This is one of the few cases where I'm going to grade this a little more stinky than the AP. I expect you to show me where you're coming from. Now, I know you are pressed for time. I know. But in terms of showing good work, first of all, you should be an approximation. Again, if you put a hard equal there, you're going to lose a point. It's an approximation. Are they equal subdivisions? Can you factor out, or are they not equal subdivisions? Not equal. So we're going to need to do trapezoids in a long way. Can I just go straight to the table and start saying, here's my first one. It's -10 and -8. You cannot. I won't take that. I demand that you show me where the freaking heck those numbers are coming from. I demand it. Now, the reason I demand it is because I had a lot of people do this. All right, I'll show you where they come from. They said f at 20 plus f at 25. Is that okay?
What's that?
There is no f in this problem. So do I have to count out for that person?
Yes, sir.
Yes. So should I count out for a person who tried to do it the right way and reward somebody who did some kind of halfway lame go to the table? You're both losing points. Okay, everybody loses, right, Dave? Okay. All right. So it is v at 20 plus v at 25 times the difference 5 divided by 2, and so on. It was -75 meters. The units point off to the side was for A and B. Did you have meters per second here? And in the explanation, did you say the displacement was meters and the time were seconds? Okay, that was 1 out of 1. Are we cool? At this point, I'm starting to lose papers because people didn't get to this point. So if you didn't get to this page, think about how you would do this for a second. This part, C.
What was you?
What was the units point for A and B? So were they meters per second squared in A, and the displacement in meters over time seconds in B? Cool.
Yeah.
Okay. C, must the particle change directions? I had a handful of people, and it's very common for people to say it has to happen in 8 to 20 because V must equal 0 there. Solid reasoning or faulty reasoning? Faulty reasoning. What does V equal 0 imply? Does it imply necessarily it must change direction?
No.
It does not. It implies it was stopped at rest. So do not say it changes direction by saying V must have been 0. That does not prove your point. You say it changed direction by saying V
Change sign.
changes sign. Okay. All right. So there were 2 time intervals. You had to say the time intervals. There must have been one here between 8 and 20 because V changed sign, and one in here between 32 and 40 V changed sign. Last but not least, part D. This is the part where I really wish you would have had time because I would have liked to have seen if you could have worked your way through it. It's a good problem. Let's look at it, shall we? Okay, so D. Suppose, I don't like how Why is that so narrow? Suppose. Stop. Okay. All right, suppose the acceleration is positive for time 0 to time 8 seconds. Why is the position of the particle at time equal 8 greater than 30? Why must that be the case? Velocity is greater than 3, okay, so? All right. So, do we know where it started? At time 0, it was at where? 7, okay. Do we know how it changed position from time 0 to time 30, or can we at least, or sorry, time 0 to time 8? Or can we at least get into that? All right. How do you find position at time 8? Initial position plus the integral from 0 to, right? Okay, that gives me a position at 8. The question is, why does that have to be greater than 30? That's I didn't know. I just started playing around. I said, okay, that's got to be greater than 30. Why? Why does that have to be greater than 30? What do they tell you? If the acceleration is positive,
So it's concave up.
concave up, okay, what does that tell me about the velocity?
That means the velocity never goes below 3.
Okay,
Velocity is always going increasing.
increasing. So what's the minimum velocity on the interval? On 0 to 8 is 3. Okay, so could we say that the velocity is greater than or equal to 3? Do you agree?
Yes.
All right, on the interval. So what about the integral of velocity from 0 to 8? Doesn't it have to be greater than the integral from 0 to 8 of 3? And what is the integral from 0 to 8 of 3?
24.
24.
And you add 7.
If I add 7 onto that, this is really saying the displacement has to be at least 24 units. And you started at 7. So your position at time 0 has to be at least, actually, let's just add 7 like you said, because I'm running out of space. It has to be at least, what is, I don't even know what I'm writing here. 0 to 8 has to be at least 31, and therefore greater than 30, right? All right. That was a good question. That was fun. Now, in terms of the scale to this, it was too long. It'll happen again. I'm just going to warn you. This happens a lot in my class. I just am a terrible judge. And you guys are just terribly slow. Terribly slow. I'm just kidding on that. 25. 4, 3, 2, 1, 20. I had, let's see if you agree with my marks. This, it was 25 point, and the best anybody did was 21. 1, 2, 3, 4 there. 1, 2, 3 there. 1, 2 at 17. 16, 15. 16 was 1, 2, 3, 4. 2, 4. 14 was 1, 2. 13 was 1. 11, no, 1, 10. Oh, 11. No. 1, 2, 3, 4. At any rate, I felt that the normal cut was here for A. So 18 and above was an A. 13, 12. I had this graph is off. 13, 14, 13. This should have been 1 and 1. This is 1, 2, 3, 4. This was a B. I guess 12 was a B. I thought that was. I know it was long, but I was generous with my scale. Is my point. Okay. All right. Then there's some other stuff here. That's all. Can I get those tests back, please? Wipe your tears off of them and hand them over.
Okay,
Yeah, turkey. I mean, oh, that's not true. It's very justified. It just wasn't nice. It's totally true.
If you're low, it's really low. Okay. A good question Bethany asked was, when I drop a page of your, I drop 2 pages of your test at the end of the semester if your homework grade is 90% or above. How much can that change your grade? Well, it depends on how low your lowest test was. But if you're the normal is usually it changes it a couple percent if somebody just had a really terrible test. So, that said, that homework grade should be above 90. I don't grade on correctness. How do you not have a homework average above 90? I write notes and I'm trying to teach you all that stuff. But you could miss all 20 problems and still get a 10. How do you not get it? How do you not have a homework average above 90? You know what I'm saying? Even I know. All right. Questions on 102? 3. 6. Did someone say 4? 3, 6, 4. 24. 1. 1. Is that the tree one?
Oh, that's on 103. Never mind.
Oh.
Sorry.
Maybe. Okay, these are 102 questions, right?
We don't have a number.
You don't have a number 6? 1B? D? B, boy? Okay, and these are all 102 questions, right? Because it really ticks me off when I get through the whole box and say, oh, never mind, it's on 102. All right. Okay. Okay, here we go. Only what? Part D? 3D? Okay, when is speed increasing? Cool. 3A, what's the equation? 2, 3, getting there. Alright, so the position was t cubed minus 9t squared plus 24t minus 8. Sweet. Okay, question D is when is speed increasing? How do you know when speed is increasing? When B and A have the same sign. Do you agree? So I need to chart the signs of the two to compare when they're the same. So the velocity is the derivative position. It's 3t squared minus 18t plus 24. That's t squared minus 6t plus 8. That's 3t minus 4t minus 2. Do you agree? Okay? In terms of where that's positive or negative, does it start at 0 or does it have negative sign? I'm going to start at 0 unless you have a problem with that. 2, 4. I think the velocity is positive, negative, positive. Now let's talk acceleration. Leaving? Acceleration is the second derivative, or the first derivative of velocity. 6t minus 8t is 0 at 3. The acceleration is positive or negative before 3. There's acceleration. Is it positive or negative before 3? Negative before 3 and positive after, yeah? So where are those signs the same? Between 2 and 3, they're both negative. And so between 2 and 3, V and A both negative. So speed is increasing. And what else? 3 to infinity or 4 to infinity? 4 to infinity. V and A both positive. So speed is increasing. Okay? That's the idea. Are we good? Okay, yes? No. No, there's no, it was factorable. There was definitely no factor. All right. 6. 6 is replaced. Sweet. Is it the region bounded by step 1? That guy? Is that the 6? Okay. So,
Just because chopped in half doesn't mean it doesn't.
y equals x squared. I would bet anything that you assumed it was first quadrant there, that there is no reason you should assume it's first quadrant. Okay, so make sure that you did the entire section. Did you? Excellent. When you revolve that around 5, do you want to use x or y for this? X. And if you use x, is that a washer or a disk when you make this revolution?
Washer.
Washer. Volume. For big R, upper minus lower. What's upper? For big R, what's upper minus lower? What's upper? 5. And lower is the parabola, yes? And for little r, what's upper minus lower? 5 minus 4, yes?
Yeah.
Okay, and the limits of integration are from 0 to 2? No.
No.
Negative 2 to 2. Make sure that your answers aren't exactly half of what's corrected. Okay, B. X equals negative 3. If you take this region, which ends at 2, negative 2, and revolve it around x equal negative 3, and use an x approach, what kind of volume approach will we use for the revolution? Shells. Volume is 2 pi r h dx. What's r? Right minus left. What's right minus left? X minus negative 3, so x plus 3. What's upper minus lower for the height? 4 minus x squared. Good? Then C, if the region is a base of a solid cross sections parallel to the y-axis that are semicircles. Then what's the volume? Thanks. So, I'm hoping that you have this memorized. Do you have a basic semicircle volume memorized? What do you do? 5 over 8 d squared. Okay, and the thickness is a dxy or dx thick? Dx thick. I don't know what I was just asking there. All right, so pi over 8, cool, negative 2 to 2 because it's x. Something squared. What is the diameter? 4 minus x squared upper minus lower. Okay? You should gradually have memorized squares equilateral triangles and semicircles. Maybe we'll build up to isosceles later, but for now, those three, and rectangles, are straight. 4, is 4 still a question?
Yeah.
Okay, it's been a while. So I believe the function is 2x plus 1. And it's on 0 to 3, if I recall. 0 to 3. Infinite right rectangles. Okay, this is a little rusty probably. So let's make sure you remember. Get me started. What is the big idea here to add all these? The area is the sum of many small rectangles, base times height. What is the base, generally speaking? Delta x. The height comes from the function at different varying incremental points. That is the big idea of Riemann sums to start with. Are you with me? Okay. In this case, delta x is a total region of 3 divided into n chunks, which will eventually take to infinity. But right now, delta x is 3 over n. Are we cool? Okay, look here. If I'm drawing right rectangles, then don't I start at 0 and go over a delta before I draw my height? So the first x is at a single 3 over n. The next x at which I draw, x2, is at 2 3 over n's. x3 is at 3 3 over n's. So generally speaking, x sub I is at the ith 3 over n, or incrementally developing 3 over n's each time. Because I'm using right, the first is 1, and the last is n, through the first rectangle through the last rectangle. Are you with me? What do I do now? Write the function. It's 2 blank plus 1, and in the blank, or the x's are I 3 over n's. With? All right, now, I'm trying to get a formula for what this adds to. That's the point, without the summation. The algebra of that, then, is a little funky, but keep in mind that this whole thing, if I were to expand it, I would get this whole thing every time, 3 over n, a 2, a 3 over n, and a 1, and it would constantly be like that, and all that would be changing is putting in a 1. Then you would get that same big mess, and then you put in a 2. And you're trying to say, all right, well, how's that at? You with me? I think you'll agree that, first of all, I could restructure this so that if you distributed the 3 over n, it would be this guy and that guy. So what I'm going to do first is split this up into the 3 over n times that stuff, and another summation of all the 1s and 3 over n's. Okay, it wouldn't matter if you found them all, then added them, or reordered them. So you should split the summations into however many terms you have. I have 2 terms going on, so I'm splitting into 2 summations. Very cool. Are you with me? Yeah. Okay. Now, in adding all these highlighted terms here, every time I'm going to have a 3 over n, a 2, and a 3 over n. Every time. And really all that's going to be changing is the 1 and the 2. So it is 100% cool to, on this guy, factor out the 3 over n, the 2, and the 3 over n, and just say times the sum of all those 1 plus 2 plus 3. You cool? All right. Well, what is the sum of 1 plus 2 plus 3 plus through n? I right, that's where the formula comes in. There's a formula for this. It would depend on when you end it. So it's a formula rather than a number, depending on where you terminate in. The rest of the stuff I'll just say is 18 over n squared. Are we cool on the substituting or dumping the first summation? Okay, the next one. I have 3 over n. Every time I'm going to get a 3 over n. So when I equals 1, I get a 3 over n. When I equals 2, I get a 3 over n. When I equals 3, I get a 3 over n. That this close? No. So how many 3 over n's do I have? N of them. There are n of them. Then you should be able to take the limit of that. Make sure I get 102 today. Okay, just hold on to you. Have a nice day. Buenos dias.
Colors. So like if it's a friction, you tie onto a tree that has friction. Would that mean that you have friction? Right? And
Yes, I get 12
No,
there.
I'll get that done.
if it was left-hand rectangles, what would you do?
If it was left-hand rectangles, this would go from 0 to n minus 1. And this formula then would actually be like this. This row. And this would be, the answer would be 6. Okay, have a nice day.
If you look at off-swing, I think friction is going to be on something that's super long.
Strange
Yeah, and that, yeah, I keep it working here. This is like,
Leave it. Micaiah, as a favor to me, do not pick up that airplane. Not well.
I mean, it lands on things pretty well.
I was trying to get it in the trash can.
Applies to gravity?
It broke bad.
It broke bad. Okay, now we're designing paper airplanes.
There's classes on that.
That's really cool.
You know, there's jobs on that too.
Yeah, there are.
You can get,
Paper airplane?
no, not paper airplane, real airplane.
Sure, paper airplanes too.
You could get a job designing paper airplane. I don't know, now I feel like I've got too much. You guys know physics.
Mine's
Ooh, that's
better.
got too much going on.
Mine's too better, Mr. Rickman.
Question is, why are you making paper airplanes in my class?
Because it was out of my skyscraper and I didn't feel like going to the trash can. Mr. Rickman.
Oh.
Right. Mr. Rickman, I mean, Cole made this.
Yeah, Cole made a very detailed swan.
Who did?
Cole, he's really good at swans.
Wow.
It even has little feet.
I'm like 90% sure that's Cole.
Wow, feet, yeah, I've never seen them. Feet.
Yeah, Cole is really good.
Was that what we did?
Cole is super talented. There's nothing Cole isn't good at.
Yeah.
Wow.
Nothing. Except public speaking. Cole's terrible at that.
Yeah, I would have mentioned you. Hello, everybody. All right. All right. Warm up. All right. Which was the
She just full sended.
Basically what she did. It's like my favorite sticker in the world. Basically,
Alright, so the question is, where's number 4? Hi. Hi. So, here?
You know my thing.
Alright, number 20. Would you first use the scratch paper, then do the proof in 20? One of those X goes to 2. 20 on tonight's homework. So this, as far as rules, here's just the 19, you do that to order. You can put it in the absolute value. You can, that's for products and portions, that's the rule, that's for differences, these differences. And you think of this this would be there's no way to get that to, so that's why you multiplying epsilon by a number, or dividing epsilon by a number, that always be safe down, because those are absolute values you want to as much as they're much, I'd love to get the grades. you have your delta yet? Hopefully. What's your delta? 2 epsilon's good, you're on the right track. All right, how we doing? Let me throw up my proof and you can compare yours to mine and we can go over any questions about what you need or if something's different between yours and mine, if it's okay and all that stuff. So I let delta equal 2 epsilon and I stated my definition of a limit. If x is within delta of 2, then it must follow that y is within epsilon of a half. Assuming we start with x minus 2 is less than delta, then it flows that x minus 2 is less than 2 epsilon. 2 epsilon, where does it come from? Well, assuming that x is close to 2, then x is between 1 and 3. That means 2 is less than 2x is less than 6. Absolute value is necessary because you're going to move that over someday down the line, and the absolute value needs to be there so you don't switch the inequality. Epsilon it up, and you get the side note that x minus 2 must not only be less than 2 epsilon, but therefore less than absolute value of 2x epsilon. If that is the case, then A is less than C. It's also less than B. And then this is the part that ticks me off. It feels like you should be pretty well done, but then there's all these other little delayed steps that you got to do to get the final result. This is where I cut corners when I was your age. Fine. And push came to shove. On the test, I could do it well, but on the homework, I probably cut some corners because I wasn't as good a worker as you guys are. You're a me. And that was a big difference. But, I'm nice, so that's all good. There we go. Once you eventually switch, you're there. All right, how is it going? Pretty good. I'm very doing well. Now, that said, just because a lot of people, including Ben, would say it's all going pretty well, doesn't mean everybody's doing well. And so if you are not doing well, you'd like to come in and just go through this together on an individual basis. It actually goes a long way. It's hard to do a lot of questions on there in a group setting. But next, I want to go, I know you saw your test yesterday. There's a couple questions I want to go over in the test, and then we'll get to questions on the homework. Here we go. The test. Put away your phone if you have it out. And while you put it away, you might ask yourself, why did you have to put it out? Why have it out? It's nothing but an anchor on your ship to success. Right? It's a terrible drag. It's like you're not able to fly. All right. I'm going to focus on the second page because that's the one that we didn't have as much time on. And there was one really great problem I wanted to talk about that probably didn't get it to do. Well, I have your other page, but I haven't read it yet. But I did find it. Yeah, did you you tell me this just on Saturday, or was that somebody else? Somebody told me, I don't know, somebody, because I was talking too long, what do you guys told me to tell me? I thought it was you, I was in a meeting and somebody, I thought you, and you honors kids, said I was talking too long, you gave me this.
I definitely did.
Shush, say whatever I want to say. I thought it was you, sorry. Alright, this test. The first page, I don't have a lot to say on the first page, because it was great. You guys are really solid here. Just as a warning, this problem is specifically designed to say, are you doing your homework well or going over your questions well? That was straight from the homework. The Newton's method problem, the only problem with that was some people had a hard time getting started. How do you get started on that? There were some people, some of your peers weren't able to get started, and they were frustrated because they knew Newton's method, sort of, but they couldn't get started. What do you do to get started? So, yeah, set them equal to each other, which is great, x squared plus cosine of x, but that's not what Newton's method solves. What does Newton's method solve? It solves for roots, or zeros. So you need to make it a zero problem. So how do you make it a zero problem? Talk to me, people. Brandon can't talk all the time. Kylie, what do I do? Subtract one from the other so that you have everything on one side. You should definitely, it's terrible math to call this F. I have people calling that F. F is taken. Call it something else, H or something like that, and then go from there. There were a handful of people that also had Newton's method wrong. It's x minus, and it's the derivative on the bottom, not the top. So as time goes on, you'll start to doubt yourself. Right now it's fresh in your mind, but I can tell you next semester if I drop this on you, you're going to start saying, plus or minus. Which one's on top? Well, it's either get out the notes or develop it yourself. Try it. This went well. I was happy there. And in retrospect, I guess I should have made this, saved some time by making this calculator, because I thought, well, I know they're going to make use of mistakes and they're going to screw it up. But nope, you pretty much killed this. Very few people made a mistake here, at least on the integration. Some people made a mistake on the evaluation, but it's great. Everybody did, not everybody, but most people did really well. Okay. Let's focus on the second page. I don't know what you understand or don't understand or what you just ran out of time for. So let's go with this. This, I'm going to emphasize it. I clearly wrote it on the board, but I'm going to say it again. When you find the error bound max, that M, this is important. This is an idea in second semester Calc 2. M is the max of the absolute value of the second derivative. I had quite a few people say M was 2. Not M is the max of the absolute value, and that is 6. Should use 6 there. All right. This was a bit of a time eater, so let's talk about this. I would have graphed this myself to start with without the absolute value. So, tell me a characteristic about this graph. What do you know? Elaine, tell me something you know about this graph. There's an asymptote, a vertical asymptote at 0. Is that what you're referring to? Okay, and x-intercept where? Aiden? 4, true. Before the absolute value, where's the horizontal asymptote, Colton? -1. All right, so I'm going to reflect this in a second, but graph-wise, then I still wasn't sure. All these negatives were pooping me out. But it eventually was, it was this kind of deal. Before absolute value. You follow? And then the absolute value changes everything. The asymptote's still at 0, but now instead of a horizontal asymptote at -1, now the horizontal asymptote is at 1. that part gets flipped up, this part flips. You still have, this part is unchanged, it's still positive, but this part gets flipped up. And so when you go to do part A, when you go from the area from 3 to 5, you should have kept original function for 3 to 4, x minus 4 over negative x, but used opposite from 4 to 5. And then integrate it by splitting it. And then evaluation was a mess there. So that's the conceptual idea. You good? All right. The EVT, I gave you a point if you just said the EVT. Absolute max must be at endpoints or critical numbers. So I expected to see that. And I think the max was 1/3 if I remember right. This was straight off the homework. For the most part, it was good. If you did it well in the homework, you did it well on the test. The free response. Let's talk here. Now, surely there are some people that never finished it. But I can tell you, there's a lot of good practice that's very common in this. And the last question is a great question. To me, that was one of the best separate the good from the great kind of questions, which is hard to do. But question part D was really good. Let's get to that. But first, I am going to absolutely freak out on the next person that says a derivative from a table equals. If you missed a point, if you have 0 over 1 here, would you go to here and circle this really big and put a big arrow at it and a little star around it? Because I am going to freak out on you if you tell me that the acceleration, which is equal to the derivative, equals the average rate of change. It doesn't. Estimating it, do they look for that? Yes, they 100% do. You better make darn sure that you're showing this is an estimate exact. I don't remember what the answers are, but it was just for the number. The units come later. They did a units part for A and B off to the side. I'll come back to that in a minute. That integral, when you integrate V, is it distance or displacement? It's displacement. In what cases is it both? If velocity is always positive, and you know that to be true, then you would say both distance and displacement and say why. But in this case, it wasn't both. It was strictly displacement. So the explanation should have been, this is the displacement in meters from time 20 seconds to time 40 seconds. The units would come from saying this was meters per second, and in your explanation saying this is displacement in meters from time 20 seconds to time 40 seconds. That was the units point there. Some people lost points here, and again, I don't know if you were just trying to cut corners because you were pinched for time. But I can tell you, when I go to grade this, if you say this approximation is, and you go straight to table, -10 plus 8 times 7, I'm counting off. That's not good enough for me. I need to see where you're coming from. Now, the reason from my side of it is this. I had some people say, all right, I know you want me to show where it's coming from. So they said f at 20 plus f at 25 times 5 divided by 2. Now is what they did okay? It's not okay. It's got a flaw. What is it? There's no f in this problem. There's no f. There's no f. It's v. And so do you lose points if you say f and there's no f? Yeah, you do. So can I count off for a person that said F and tried to do it the right way, but not count out for this lame-o who doesn't even show me where they come from? They just go to the table? Oh, no, I'm counting out for both. Everybody loses. I'm taking out everybody. Okay? So yeah, it should be, good work is V at 20 plus V at 25 is 5 divided by 2. And then continuously on. You couldn't factor out a greatest common factor because the deltas were not equal. So you shouldn't have had a delta x over 2, 1f, 2f approach. You can't do that. Okay? C, the main issue on C was C, there was one common mistake on C, and that is, it said, when does it change direction? I had a handful of people say it happens from 8 to 20 because V must equal 0. True or false? Or does that satisfy? Why not? What does V equal 0 prove? Does it prove it changes direction? No, it proves it stops. That's not the same as changing direction. So would it be satisfactory to say V equals 0? No. You must say V changes sign. You have to say changes sign. Okay. Last but not least, D. D was a good one. That was a quality problem here. So let's go back here and dump this writing. All right. So D, it says, all right, I'm telling you the acceleration of the particle is positive for time 0 to 8. Why must the position at time 8 be greater than 30? They told you earlier that the position at time 0 was 7. And so the question is, why, or prove, the position at 8 has to be greater than 30? How do you do it? What does the acceleration imply? What does this tell you? Velocity is increasing. If it's accelerating, velocity must be increasing. So what's the minimum velocity on the interval? Is here's 0 to 8. If it's increasing, then the very least the velocity can be the whole time is 3, right? So what does that mean? So I'm going to do this in a kind of thinking way, and then we're going to do this in a well-written, justified calculus way. If you're going at minimum 3 meters per second for 8 seconds, what is the minimum displacement you'll go at least 24 meters. Now, if you started at 7 meters and went at least 24 meters, then you ended at least 31, and therefore greater than 2. Now, the hard part is, how do you say this? Now, a lot of people get that. I can tell you from when you have sufficient time, a lot of people get that. The common mistake, there are some people that don't know what to do, so now you know what to do. But there are some people that write me the great American novel. There's a whole paragraph. Symbols were invented for a reason. Use them, okay? If you look at the original Pythagorean theorem, it's like a paragraph. It's not a squared plus b squared equals c squared. It's this long, wordy explanation. Symbols are delightful. So you're going to prove that position is greater than 30, right? How do you find position at 8? Position at 0 plus the integral or the displacement from 0 to 8, okay? Okay. Now, let's talk about how do I use the fact that v has to be always greater than or equal to 3. Now, if acceleration is positive, that implies that v is always greater than or equal to 3 on the interval, yeah? So what about the integral from 0 to 8? Doesn't it have to be greater than the integral from 0 to 8 of 3? And therefore, the integral from 0 to 8 on the velocity has to be greater than or equal to 24, yeah? So that said, the position at 8 has to be, if this has to be greater than or equal to x of 0 plus 24, and therefore the position at 8 has to be greater than or equal to 31. Yeah? I didn't say that very well, but I kind of fudged it. I'm good here. You with me? Okay, can I take that back, please? Do you have a question? All right, questions on, you still have 102, or did we finish 102?
Wow, working on it.
Come on, Kylie. Thank you. Thank you. All right. I didn't hear you. 102, we're done. Awesome. Something else.
I still wanted to.
102, Allison did not turn to 102. Did you also not turn to 102?
It is for the year to date.
No, I don't. I was wondering what this one was.
No. All right. Thank you. Thank you. Thank you. So many spread here we go. 102. What questions have we not done on 102?
Finish.
4 is that Riemann sum problem. Okay. And what else? 1, 2. Okay. 19 and 13. All right. There we go. Where's my 102? All right. When we last checked in we were talking about the area. This is a bunch of bases times heights, and after doing a lot of work, we got to something like this step here, I believe, or something close to it, yeah? All right, so first thing is, when you go to split this, the algebra of it is however many terms you have, if you were to distribute, that's probably how many summations you're going to want to break this into. I would eventually break this into 3 over n, 2, 3 over n, 5s, and 3 over n 1 time. That is allowed by rules of summations. You're still going to add everything the same. It's just going to be in a little different order that way, but it's the same sum. You with me? Okay, now if I were to actually write this out or teach some little kid what this means, it would mean that still stays there and I put in a 1. And then I add to that, that still stays there, I put in a 2. The point is that still stays there every time. So I could factor it out there so I didn't have to write it every time and just say, what's the result when I take out that greatest common factor and add 1 plus 2 plus 3? Well, what is the sum of 1 plus 2 plus 2n? It will kind of depend on where you cut it off in. But the formula for it is, that's where I put that in the box, the formula for the sum of a bunch of integers going up by 1, starting at 1, is that. The 18 over n squared is still there. Really cool? Now for this, when I equals 1, what do I get out? A 3 over n. When I equals 2, what do I get out? A 3 over n. When I equals 3, what do I get out? A 3 over n. So obviously I'm just going to get a ton of 3 over n's. How many? N of, yeah, I'm going to get 3 over n times. And so as wacky as that is, it adds to 3. Now, that's the sum formula, just so we're clear on what the heck we just found. That's a formula that would give you rectangle estimates based on however many rectangles you wanted to use. If I wanted to use 1 rectangle, I could plug n equal 1 in, and that would give me a 1 rectangle right Riemann sum. The point, though, of this, to get a formula, is so that I can take the number of rectangles to infinity. This, you'll have a dimension match here, n squared over n squared, so the end behavior just approaches 9. 3, obviously. So here's 12, which you can verify by trapezoid error. You with me? Or integral? Does that make sense? Yeah. Okay. As far as I got this question 3 times yesterday, is that on test? Is that on test? Because I suck at that. Well, that would never be a free response because it would be a grading thing. But it is very common that you would get something like, hey, this summation 2 over n of square root of 1 plus 2 over n I times is equivalent to what integral? Which of these integrals? That is pretty common. Is equivalent to what integral? I can imagine 2 different. Give me 1. What would you know about the limits of integration? Let me start there. You wouldn't know anything about the limits of integration. That's such. You should know that they are how far apart? 2. So if you had 1 to 5 here, I would hope you'd say that. Well, I know that's not it, because the delta x is dividing a region that's 2 wide in part. So they better be 2. Now the question is 1 or 3 or 0 to 2. Well, that's a 1. It's possible it's starting at 1 because I see a 1 there and going up to 2. So this is possible if the function is just straight up square root x. This is possible also. What would the function be? Yeah, 1 plus. Obviously, they wouldn't both be there. They'd just be over. Okay. We'll practice that more, is my point. Don't freak out if you're really rusty at those. It's good to let it not get too rusty. Number 1, is number 1 still a question? And it's out of the book, it's not changed, correct? All right, did A go fine, and the question is on B or both of them? B. All right. I will tell you equilateral triangles inscribed. Okay. Those sectors don't equal segments don't area. All right. So you know stuff about the radius, I believe, yeah? I think you're given stuff about the radius. So my advice to you is on part B, when they say how fast is the area of the triangle changing, don't do base height divided by 2. Instead, use 1/2 AB sine C. The reason being that the area of this triangle, I don't know if you remember back in the green book, I think you probably learned this from Ms. Smith, but you would typically do any polygon by breaking it up into many triangles. So the area of this is 3 1/2 AB sine C. The reason you like it that way is because then you're able to get those radii in there without splitting it and all that stuff. It's gross. 1/2 AB sine C makes it 3/2 r squared sine what central angle? 120. 120 is root 3 over 2, so 3/2 r squared root 3 over 2. If you do 3 root 3 over 4 r squared for your area and do your calc on that, it'll go fine. You cool? Are you with me? Okay, cool. 2, question on 2. Is 2 still the question? Does everybody need 2? Guess not. How about 19?
Yes.
Okay, 19 is yes. Recall those identities. Where's that? Okay. Here's the deal. I think it's easy to separate the variables here, but when you go to integrate this, how would you recall these identities? Why did I write them?
Choose sin x cosine x.
Yeah, I mean, I understand that, but do you really need to use them? Can't you just integrate this?
Yeah.
What was I thinking? I don't know, what did I think? Was the answer different? Oh, well, I don't know what I'm thinking here. Oh, sorry. So your question is probably, what do you mean? Why do I have to use the identities? The answer is, I don't know. I don't know. Forget the identities and just do normal integration. Sorry, I don't know. 13, is 13 still a question? Yes. For Pete's sake, don't look at one of the differences. We know what does that mean. Okay, so yeah, 13 is a little wacky. These are hard. There's a lot of gray area here, it seems like, next to the, no, sorry, this is squared and fourth. Okay. Aren't both of these going to approach infinity as x goes to 0? So that is an indeterminate form, yeah? So if it's indeterminate, you go to quotient form, and that would be something like x squared minus 1 over x to the 4th, yay? Okay, now is that indeterminate and therefore L'Hopital? As x goes to 0, this goes to negative 1 over tiny. And so negative 1 over tiny to the 4th is I don't know or I know? I know. Negative 1 over tiny to the 4th power is infinity or negative infinity? Negative infinity. Okay, it is not actually infinity. All right, and that's all. Good on 102. 103. 103? Questions on 103? 4? 9? 9, like you're not sure if you want 9 or 9? Do it. Do that, baby. 103, 9. How did the proofs go? The delta epsilon. Oh, 9, that's 9. Ah, my bad. Okay, so I'll be anxious to see how you did. Each one of these requires a little different creative step. Let's see how you did, shall we? Scratch work. Again, I'll say it again and again. I don't want your scratch work. Don't do it on the homework. Do it somewhere else. Okay? I want you to look brilliant. So the scratch work is over here, starting with the idea here. I want to get to eventually x minus 4 is less than something, yeah? How do you get from there to there? Please. I don't think I want to square both sides. Did you square both sides? Please tell me you didn't square both sides. All right. Well, let's multiply by something. What can we multiply by? Root x plus 2. Now you're talking. All right. I think you'll agree that the left side will be great. Now your x minus 4 is there. The only question is, what's the right side in a numerical way, not an x-ish way? Delta should not depend on x in epsilon. It should just be a numerical form of epsilon. So, how do I get a numerical form of root x plus 2? How do you get a number? You start by saying x is between 3 and 5, close to 4, so between 3 and 5, which means root x is between root 3 and root 5. So root x plus 2 is between root 3 plus 2 and root 5 plus 2. Throw in an epsilon there, and what do you make your delta? Delta is epsilon times root 3 plus 2. So, if you're thinking, man, my proof, I think I understand, but my delta is really wacky. Yes, it is. So, here we go. Let delta equal epsilon times root 3 plus 2. Okay, if you say so. If x minus 4 is less than delta, it follows that f minus 2 is going to come out less than epsilon. All right. Shall I go through the proof, or now you see it?
I think I should be fine for
Okay. All right. Let me know if you would like me to do the proof, but make it look good. Other questions on 103? One? Okay. One is, oh, is this the tree? This came from my butt the first time I taught this. I could not understand where their answer is coming from. But now I understand. Okay, so, tell me this. Is it going okay and you got to $12 and something for the tree price? And then it all fell apart? Or you didn't get to that $12 Okay, so we'll build it. Now, if you got to that $12 part, you weren't sure where their answer is coming from, I'll tell you this. The problem is, you can't have part of the tree. You can only have a whole tree. So you really need to find the price on either side of whole trees and find the whole tree case to maximize revenue. But I will build up there eventually. Let's start from the very beginning. It goes like this. Sells a tree for $20, sell 25 trees a day, increase the price, cha-cha-cha. At what value should you fix the price to maximize daily revenue? Now, I was taught to do optimization this way. You start by making sure you understand the question. I'm trying to maximize revenue. Second is you get an equation for that which you're trying to do. When you sell something, the revenue depends on how many you sell and the price that you're selling. So N times P. Then, before you maximize, you try and get it from 3 variables down to 2 variables through some other relationship. And that's the hard part of the problem by far. The rustier I am at these, the more I kind of have to think my way through this. So I've done this problem 3 times in the last day, so I remember it, but I'm going to walk you through my thought process. I said I don't know what the freaking heck is going on, but I do know that when I get stuck, I tend to draw pictures. It helps sometimes get me unstuck. When I set the price at $20, I sold 25, and every time I jack up the price at $1.50, I sell 5 less trees, 7 more trees. Oh, lowers the price, 7 more trees. Oh, well, it's either way. It's fine. Okay? So, or 32. Now, because that for every, and that constant rate of change between price and number tells me it's a linear relationship. Then I said, okay, I can write an equation in line. I have to get through all the words, but I can do equations in line. I said, all right, instead of x, y, price is x, and number sold is y. And the case they give me is price of $20, 25 sold. And I thought, all right, now the slope is change in y over change in x. Generally, in this problem, that means change in n over change in p. So how does the change in n over change in p go? I think they said I sell 7 more trees for every decrease of $1.50. And then I guess I decide, is that, do I leave it alone or do I clean it up? I don't like it. I'm just going to double and call this negative 14 thirds. Is that okay? All right. So the function, instead of y minus y1 kind of stuff, I'm going to go n minus n1 for my equation. So my equation, I think, would look something like n minus 25 equals negative 14 thirds of p minus 20 bucks. Really cool? So n is 25 minus 14 thirds p plus 280 thirds, or negative 14 thirds p plus 355 thirds. No, he's giving me some nice numbers. This is terrible. All right, you follow me? So far, so good? Alrighty then. Now, the revenue function can be written in the single variable p. If I plug that in, negative 14 thirds p squared plus 355 thirds p. Cool, here we go. Revenue prime is negative 28 thirds p plus 355 thirds. At this stage, I thought I was home free, but it turns out I wasn't. I get a price of 355 over 28. And 355 over 28 is something weird. 12-ish, if I remember right. $12.68 ish, yeah? Now that is not the correct answer, nor does that yield the max revenue. The problem is that this, while price can be continuous, number of trees is not continuous. It's called discrete, which is to say countable. I can't have if I say 12.68, that doesn't trace back to a whole number of trees. I can't do that. It's either got to be one side or the other. So I really, this is where I got kind of ticked, because at that point I was back. And now I have to figure out what's the price on either side of this that has whole trees. So frustrating. Okay, so when P is 1268, the number of trees is negative 14 thirds of 1268 plus 355 over 3. Yeah? So that number of trees is the, that's something clean. That's 25. I guess that wouldn't be terrible to do by myself, whatever. Okay. I'm so tired. Plus, times. Please tell me somebody's paying, just one person, that's all I need. Is one person paying attention? Okay. Okay. You're with it. Whoever said yes, I'm doing it. Okay. So this is 59.16 trees. So the question is, which is better? The 59 trees and the price that goes with it and therefore the revenue, or the 60 trees and the price that goes with it and therefore the revenue? That's now the question we have to ask. You down? Okay, well, so now, how do I find the price if the number of trees is 59? Yeah, I have to plug in here, I have to go, if this is 59, it's so, I mean, I love math, but this is starting to tick me off, man. So, I get something like 59 minus 355, but at this point, did you just say you're going to write down a bunch of gibberish?
Well, no.
You said that way too loud.
But at some point, your head's gonna start cramping.
No, no.
Just fling some absolute lies.
What? No. I refuse to quit now.
You swear.
God, jeez, what a mess. I made a mess. Let's try again. 59 minus 355 divided by 3 times 3 divided by 1. I got 89 sevenths. That doesn't make sense. 89 sevenths. 12.71 cents. So, $12.71. And if I do 59 trees at $12.71, I collect $749.89. Case 1. Case 2. If the number sold is 355 or 60, oy, oy, 355, but I'm not quitting now, baby. Still don't care. I'm still doing it. I get, what the heck. Bye. I'll see you tomorrow. I might still be doing this problem. Divided by 3. Times 3. 1250. Oh, that's nice. 1250. Oh, I'm so close. $750. So I should set the price, look at that, you make 11 more cents by letting the price equal $12.50.
Boom.
Yeah, boom. Boom. Oh. Are you okay? Oh my gosh, that was terrible. I almost killed somebody with my pen because I was dumb. Man, don't sue me. Your dad's not a lawyer, is he? Wow.
Can you walk through number 2?
Number 2? So 103 is due today, but or 102 is due today, but not 103. We didn't get through 103. Yes, I can get through 2. Are you sure you're okay? Yeah. Okay. 2. Yes. The best way for me to go was to do this in terms of distance west and distance north, and then distance between them. The west one was 40 miles per hour, and I made it positive because although it's going west, the distance is increasing. And the distance south, the car going south was doing 50 miles per hour. All right, and you want the rate of change between the two. ddt, what's the equation you use? Pythagorean theorem, yeah. Do that and differentiate with respect to time. Yeah. And the only thing after that is, as far as plugging in the instant, that was a little bit rough because the cars were passing through the intersection at a different time. So for the instant, you'll have to be careful to find the distances. But that might get you started. Does it get you started?
I'm having trouble taking
So yeah, what is the derivative with respect to time of that side?
1 over
Just 1 d dt, yeah?
equals 1 over 2 square root of d
This is a west, sorry, dw
d south squared
times
2 dw
dw dt plus 2 ds dt. Okay. So you have 1, 2, 3, 4, 5, 6 different things you have to plug in. Actually, they're not all different. So I.
There's the distance west and the change in distance west the same because it's only for an hour.
Yeah, the rates stay constant. It's the distance instants that are wacky. That first west, he goes 40 miles per hour, but you have to eventually figure out how long did he go.
You didn't say how fast changing 1 hour after this?
Yeah, but if you read the first one passed through the intersection 30 minutes before the second one. So in terms of the westbound car, it doesn't travel for an hour, it travels for an hour and a half, I believe. Is that right?
60, or would it be 20?
30 miles, 30 minutes later, it goes from south, southeast, so the south goes for an hour, the west goes for an hour and a half. So I think the west is 60.
Doesn't the west get there 30 minutes before south?
So let me think about this. So the west gets through the intersection first.
Right.
It goes for a half hour until this car gets there, and then this car goes for an hour. This car goes for an hour. So I think the west That was 30 minutes before and an hour, so the west is 90 minutes.
Okay. That'd be for 60 in my.
So 60 for the west and 50 for the south? And so that's not, I was hoping it would be a triple, but I guess it's, oh, you don't, never mind, you don't need the head pump. Hi. Oh, thanks. Okay, hi.
Are we just doing 60 tonight, because we didn't get asked?
No, probably Monday.
59 is due?
59. Alrighty.
Substitutes. You go under? No, let's go to Spanish. Well, that's the meal part of Spanish. Thank you, Mr. Rickman.
You're welcome. Have a good day. That's how required. Alrighty. Thank you. All right.